So hi friends and welcome back. In previous video we had discussed about the law of conservation of energy and we had seen the conservation of energy in the spring mass system. So in today's video we will discuss about the energy method. Now you will think that why to learn this energy method? So this energy method is useful in finding the natural frequency of the given vibrating system. Okay, I advise that if you had not seen the previous video, then please go and see that first, then only you will enjoy this video lecture. And please don't forget to subscribe my channel. If you have any doubts, then please ask me in the comment section. Now without any further delay, let's start. So now we will start. So our energy method is based on the law of conservation of energy. Now in free damped vibrations, no energy is transferred to the system or from the system. So therefore the total mechanical energy, that is the sum of kinetic energy, and this is kinetic energy and this is potential energy, remains constant. That means that is total energy E equals to kinetic energy plus potential energy. This remains constant. Okay. So this energy method is based on the law of conservation of energy. Now we will see that how to solve the sums using this energy method. So now find the natural frequency of the given system. So this is the given system, that is vertical spring mass system. The spring is having the stiffness K and mass M is suspended. Now we will solve this sum using energy method. So first we will draw. So this is the mean position of this spring mass system, and from this mean position we had pulled this mass in the downward direction by x displacement. So we will write let x is equals to displacement of the mass in downward direction. So according to energy method, now we know that this energy, total energy, is equals to kinetic energy plus potential energy is constant. So if we derivate this total energy with respect to time, that is dE by dt, derivative of total energy with respect to time is equals to d by dt of this kinetic energy plus potential energy is equals to what? It will be 0. Why 0? Because the energy is constant. So if we derivate the constant term with respect to time, then we will get 0. Now we will see the kinetic energy and the potential energy in this spring mass system. In previous video we had seen that we have two types of kinetic energy and two types of potential energy. So two types of kinetic energy is, first is linear kinetic energy and second is rotational kinetic energy. So in this case you can see we have only linear motion, so only linear kinetic energy will be there. And we had also seen these two types of potential energy, that is spring potential energy or strain energy and gravitational potential energy. So about the gravitational potential energy, we had discussed in the previous video that in the vertical spring mass system the gravitational potential energy is going to be cancelled. If you not seen that video, then go and see that first. In that video I had discussed the detailed derivation that how the gravitational energy is going to be cancelled. Okay, so here in our case there will be only linear kinetic energy and spring potential energy, that is strain energy due to this deformation or elongation of this spring. Okay, so we have this equation, that is d by dt of kinetic energy plus potential energy is equals to 0. So what will be the kinetic energy? If the mass is kept here, then I will release it, then this mass will have a velocity. So due to the velocity, the mass will have linear kinetic energy, that will be half mv square. Now what will be the potential energy of the spring, that is strain energy? It will be half k into x square. So this k is the stiffness of the spring and x is the displacement of the spring. Now how this formula had came, we will see. So this is the graph of spring force versus the deflection of this spring mass system. Now if we pull this mass in the downward direction, that means our deflection is increasing. So with the increase in the deflection, there will be increase in the spring force. Why? Because we are stretching the spring, and spring force is equals to stiffness K into deflection. So with the increase in the deflection, the spring force will also increase. So this graph will be a linear graph in the increasing manner. So if we find this area under this graph, this area, then we will get the strain energy. So this will be the area of this graph will be, this is spring force, let's say Fs, and this up to this we have x deflection. Okay, so this is the right angle triangle. So area will be half base into altitude. Base is x into altitude is Fs. So what is the spring force? It is half x into spring force is k into x. So we will get half kx square. So this is the strain energy of this spring. So the area under the graph of spring force versus the deflection will give the strain energy, which is half kx square. Okay, now we will differentiate this, but before differentiating we will convert this into x dot form. So velocity is what? Velocity is equals to dx by dt. Differentiating the displacement with respect to time, then we will get velocity. So it is x dot. Okay, so we will write this d by dt into half m. So this is v. So x dot the whole square plus 1 by 2 into k into x square, which is equals to 0. So I will rub this part. So if we differentiate this, it will be 1 by 2 into m into 2 x dot into x double dot. How I will show? First, this we will write 1 by 2 into mass. Mass will remain constant. So this will be 2 into dx by dt, that is x dot, into d square x by dt square, plus 1 by 2 into k into 2x into dx by dt. Okay, which is equals to 0. Now this 2 and this 2 gets cancelled. We will get m. This dx by dt will be x dot. So x dot, and this d square x by dt square will be x double dot, plus k into x dot, again dx by dt, which is equals to 0. So now you can see we are getting x dot as common. So bringing x dot out, so we will get mx double dot plus kx is equals to 0. So you can notice that we are getting this equation of fundamental equation of vibrating system, free vibrating system. So this is mx double dot. Okay, so from this equation we can see that x dot can never be 0. Why? Because x dot is what? X dot is velocity. So velocity can never be 0. So the remaining term, that is mx double dot plus kx, will be 0. So this is the equation of motion of free vibrating system. So this will be x double dot plus k by m into x is equals to 0. So let this equation as equation 1. Now we know that fundamental equation of simple harmonic motion. So what is the fundamental equation of simple harmonic motion? That is equation of SHM is x double dot plus omega square n into x is equals to 0. So let this as equation 2. So if we compare this equation 1 and 2, then we are getting this omega n is equals to under root of k by m, and this SI unit is radian per second. So if you want to find the frequency, f is equals to 1 upon 2 pi under root of k by m. So this will be hertz. So this is the natural frequency of the given spring mass system using the energy method. So we will again revise that. First we had displaced the mass in downward direction by x displacement. So according to energy method, we know that total energy, that is total mechanical energy, is equals to sum of kinetic energy plus potential energy will remain constant. So if we differentiate the above equation with respect to time, that is dE by dt, then we will get 0. Why 0? Because E is constant. Now in our system, in our spring mass system, we can see only a linear motion. So linear motion is there, so we will get a linear kinetic energy. And the second energy will be spring potential energy or strain energy. Now if you have any doubts regarding the gravitational potential energy is not why it is not written here, then go and see previous video. In that video we had discussed the detailed derivation that why this gravitational potential energy is removed or it will going to be cancelled. So if we differentiate the above equation by writing half mv square as kinetic energy plus half kx square as spring potential energy or strain energy. So before differentiating, we will convert this velocity in the x dot form. So velocity as dx by dt can be written as x dot. So half m x dot the whole square plus 1 by 2 into kx square the whole square is equals to 1 by 2 k into x square is equals to 0. Now if we differentiate this term, then we will get x dot, we will get mx dot into x double dot plus kx into x dot is equals to 0. So again bringing the x dot as common outside the bracket, then we will get mx double dot plus kx is equals to 0. So as x dot can never be 0, why? Because it is the velocity. So mx double dot plus kx is equals to 0. So this is the fundamental equation of natural vibrating system. This is the equation of motion of natural vibrating system. So if we divide this mass, we will get x double dot plus k by m into x is equals to 0. So let this mark as equation 1, and we know that fundamental equation of SHM, that is simple harmonic motion, is x double dot plus omega square n into x is equals to 0. So comparing these two equations, we will get omega n is equals to under root of k by m, and natural frequency will be 1 upon 2 pi under root of k by m, which is hertz. Okay, now we will solve the next sum. So now before solving the next sum, I forgot to say one thing, that where this energy method can be used. So this energy method can be used where the dampers are not there. So damper is, if you have a system like this is the pulley, and here we have connected a mass, here connected a spring, and here we have mass. So in this figure you don't see a damper. Now if we have a system like this is the spring, this is the damper, and here we have connected a mass. So this thing is a damper. So in our system, if we have a damper, then we cannot use this energy method. Why? Because in damping we have a friction force, and we know that friction force is not a conservative force, it is a non-conservative force. So whenever we have a non-conservative force in our spring mass system, then we cannot use this energy method. So remember that energy method can only be used where the dampers are not there. Okay, now you will think that here there is a friction in string and pulley. If there is not a friction, then string will suddenly drop down, it will not rotate this pulley. So that friction, the friction between this spring and the pulley can be neglected, but the friction of this damper cannot be neglected. Okay, we have to take into consideration. So wherever we encounter a damper, then don't use this energy method. So this energy method can be used where the dampers are not there. So this is the next sum, that find the natural frequency of the given system. So this is the disc which is connected with the spring, and the spring is connected with the fixed end. So this disc is rotating without slipping, that means pure rolling condition. Pure rolling condition, because the disc is rotating without slipping. Now here also you can see a friction. Friction is there, then only this disc can undergo a pure rolling condition. But this friction can be neglected, but the friction of damper cannot be neglected. Okay, now we will solve. So the solution will be, here if we give a displacement of this disc by theta angle, that means what will be the figure I will draw. So when we rotate this disc, then disc will be undergone a angular displacement. So let theta is equals to angular displacement. So if this point A is here in the mean position, so this is the mean position of this roller. When we rotate this roller by an angle theta, then this point A will go here and it will be A dash. So it will subtend an angle theta. So now we know that arc length is equals to theta into radius, or radius or theta is equals to arc length upon radius. So from this equation we got arc length is equals to theta into radius. So arc is equals to theta into what is the radius? Radius is r. So theta into r, it will be r theta. Arc is equals to r theta. Now whenever theta is very small, then we can consider, when theta is very small, then we can consider arc as a linear line. Arc as linear. So our linear displacement will be x. So x is equals to r theta. So we are getting our first equation, that x is equals to r theta. Keep it aside. So x will be equals to r theta. So now according to energy method, we will solve according to energy method. So what will be energy method? That is, according to energy method, I will write directly, that is d by dt of kinetic energy plus potential energy is equals to 0. So here we have two types of kinetic energy. That is, due to the rotational motion there will be a rotation kinetic energy, and due to the linear motion of this roller there will be a linear kinetic energy. Means two type of kinetic energy will be there. Now potential energy. So we will have a one type of potential energy, that is because of the deflection of this spring, which is half k into deflection square. So this will be d by dt, which is half mv square plus half I omega square. Omega is angular velocity, plus half k x square, which is equals to 0. Now we will convert the whole equation into angular form or linear form. So we have to convert the whole equation into a either angular form or either a linear form. So we will convert it into a linear form. So converting into linear form, you can also convert into angular, okay, not a big deal. So it will be d by dt of half m v square plus half I omega. Now we know that linear velocity v is equals to omega into r. V is equals to omega r. So according to this equation, omega equals to v upon r. So omega is v divided by r the whole square, plus 1 by 2 into kx square. So you can see the whole equation is converted into linear form. So whenever you get a one as angular form, angular term, and other as linear term, then convert the whole equation into either angular or either linear. Okay. Now we will convert into x dot form. So it will be d by dt of 1 by 2 into m. So v will be x dot square. This is x dot plus 1 by 2. Now this I is the mass moment of inertia about the center of gravity. So the mass moment of inertia of the disc will be m r square divided by 2. Mass of this disc is small m. Okay. So it will be mr square divided by 2 into v upon r the whole square plus 1 by 2 into k. Okay, we are converting v into x dot. So it will be x dot into k into x square is equals to 0. Okay. Now I have to rub this term. Now we will differentiate this term. So it will be 1 by 2 m into 2 x dot into x double dot plus 1 by 2, so this r square, so it will be x dot the whole square and this r square. So this r square and this r square gets cancelled. So it will be 1 by 2 m into 1 by 2 m by 2 into 2 x dot into x double dot plus 1 by 2 into k into 2x into x dot, which is equals to 0. We are differentiating with respect to time. Now this 2 gets cancelled, this 2 gets cancelled, and this 2 also gets cancelled. So we are getting mx into mx dot into x double dot plus 1 by 2 into mx dot, this is x dot into x double dot plus k into x dot, which is equals to 0. So this 1 by 2 mx dot into mx double dot plus mx dot into x double dot will be 3 by 2 mx dot into x double dot plus kx into x dot, which is equals to 0. Now we are getting a common term, that is x dot. So bringing x dot out, we will get 3 by 2 m into x double dot plus kx, which is equals to 0. Now x dot can never be 0. X dot can never be 0. So the remaining term will be 0. So the remaining term will be 0. So 3 by 2 into mx double dot plus kx is equals to 0. Now dividing the equation by 3 by 2, we will get, dividing the whole equation by 3 by 2 into m. So we will get x double dot plus k divided by 3 by 2 into m into x is equals to 0. So let this as equation 1. Now equation of simple harmonic motion will be, you have to write the whole statement, that is fundamental equation of simple harmonic motion will be x double dot plus omega square n into x is equals to 0. This is equation 2. So if we compare this equation 1 and 2, then we will get omega n is equals to under root of k by 3 by 2 into m. This is radian per second. So if this 2 goes upwards, so omega n equals to 2k by 3m under root of 2k by 3m radian per second. Now our question is to find the natural frequency. This is natural angular frequency. Now we have to find the natural frequency. So it omega n is equals to 2 pi fn. So fn will be under root of 1 upon 2 pi under root of 2k by 3m radian, 2k by 3m hertz. So this is our final answer. This is the natural frequency of this system. Okay, that is 1 upon 2 pi under root of 2k by 3m, where k is the stiffness of the spring and m is the mass of the disc. Okay, so this is all about the energy method. So that's all. I hope you had enjoyed this lecture. If you have any doubts, then please ask me in the comment section. Please subscribe to my channel for more educational videos, like and share. In next video we will see the relays method. So this method is also useful in finding the natural frequency of given vibrating system. So stay tuned and have a good day.